In this presentation, an overview of the initial 5 designs will be given, followed by a discussion on the decision matrix. The benefits of using additive manufacturing and the process chain will briefly be discussed. Lastly, the final concept will be presented.
Due to the elevated level of competition that exists in the automotive industry, there is an exponential drive towards AM. In modern days, everything that can generate a profit has to be done in less time at a lower cost. 3D printing gives the opportunity for various business models to experiment at a much lower cost, to design products, and to test innovative ideas much faster. The reason for using AM instead of conventional manufacturing is because of the promising benefits it entails. AM has environmental, geometric, and cost benefits. Components can be produced at a much lower weight, which can lead to vehicles consuming less fuel and in turn contributing less carbon emissions to the environment. The process of 3D printing enables the production of complex parts with better functionality, greater strength, and minimal material. There is a high demand for individual customization in the automotive industry due to customers having different preferences. AM is a positive investment due to the flexibility it provides as companies in the automotive industry can introduce new partners and produce prototypes in a brief period. Automotive companies can save money by eliminating the need for outsourcing through 3D printing.
During the first step in the design process, 5 sketches of gadgets were produced. 3 of the gadgets formed part of the medical industry and 2 of the automotive industry. The first design was of a medical syringe with an inclined nozzle restricted to 45 degrees. A flattened thumb ring was included to ensure convenient printing and increased ease of multiple fluid transfers. The second design was an ear curette with a cubic handle for firm grip and narrowing stem bent at 45 degrees for a better view during cerumen removal. The third design was a modified intrauterine device to be more effective and comfortable for the user. The fourth design was a gear shift knob with a more ergonomic design. The fifth design was a phone holder designed for utmost stability and support of the phone. The holder connects to the fan flaps of a dashboard, allowing the phone to be at a viewable and accessible position. A decision matrix was then used to rank the designs. 3D printing and cost effectiveness were given the highest ratings to ensure that the products would be cheap and easy to manufacture, lowering the prices to be viable for the average consumer. Functionality was given medium preference as most of the designs were similarly scored, and thus higher preference would have made slight difference to the end result. Novelty and aesthetic appeal were given the lowest weightings because the designs had little decorative significance, and most were adaptations of pre-existing concepts. At the end, despite being the least printable of the 5 designs, the phone holder was chosen for its high novelty value and aesthetic appeal.
Once the final design was selected, the design was digitally recreated using computer-aided design software. This digital version was then imported into 3D printing software. The most effective orientation was decided on, minimizing both the support material and the amount of post-processing required. Once converted, the files were sent to the 3D printer so that the 3D printing process could begin.
Additive manufacturing will be too expensive to use due to mass production of the product. Therefore, a conventional manufacturing method known as injection molding would be used to produce the gadget. Plastic injection molding is the process of melting plastic pellets, which are thermosetting or thermoplasting polymers, that once malleable enough are injected at pressure into a mold cavity, which fills and solidifies to produce the final product.
Holder has been designed to give the phone the maximum amount of stability possible by supporting the phone at its critical points to decrease movement while not compromising its accessibility. This holder can be used by smartphones of all shapes and sizes and gives the phone access to its charging and auxiliary ports. The back of the holder was carefully crafted to easily clip onto the fan flaps manufactured in the majority of modern cars, which allows the phone to be at an optimum height for calls, music, GPS, and so on. This product should increase the safety of a normal car ride, as it gives the driver a hands-free experience while being at a height which will allow the driver to keep their eyes on the road while still being able to see the phone. This design provides functionality and accessibility with a smart aesthetic to modernize any car.